Well, hi, good morning. Thanks so much for joining me in my shop here. Another beautiful sunny day, May 19th. What month is it? May 19th. So, I'm ready to bang my head against the wall. Another shot of this radio. And in thinking about this, while I was falling asleep last night and again this morning when I woke up, I started thinking about this radio and what is wrong with how I'm approaching it, or what is going on, what can I do that's different. And I kind of hit on the idea that I really haven't looked into the volume control close enough. Now, it's not that I think the volume control is broken. I don't think it is. But what I do think is the volume control is providing a lot of hints on what is wrong, and I hadn't paid enough attention to that. Excuse me. So I'm going to try to think my way into finding the problem this morning. Yeah, I wish myself a lot of luck on that. But so the volume, excuse me, the volume control. Let's just take a peek at it before we start looking at the schematic. Volume control is typical of volume controls in radios like this. It has the usual 3 terminals down at the bottom, but it has an extra one around the back here. The purpose of this is never clear to me. Maybe in some radios it's used in different ways. In this radio, well, we'll take a look at the schematic. I don't want to say too much without studying the schematic. The radio exhibits this feedback, or motorboating, we'll call it motorboating, fairly consistently. But it is varied a bit by varying the setting of this. Mostly varying the setting of this. This is where I really haven't studied this close enough. And I changed a resistor over here, which changed the bias on a tube. That changed it a little bit. I think that's really telling me that it's the tube that's involved with the oscillation, not the cause of it. It's just the amplifying element that has to be there for you to have an oscillation. The motorboating characteristic, that kind of stuff, usually tracks back to the automatic volume control system, the ABC system. But I haven't been able to prove anything at all here about any of that. Okay, so why don't we start with the volume control behavior. I'm not even going to turn the radio on. So when you get above a certain point in turning the volume up, the radio's own internal sound starts coming through. Below that setting, all you get is the thump 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 and all that stuff. You can never hear the radio below this certain spot in turning this up. Right on that spot, a lot of weird things happen. The sound becomes very shrill as it fades out. There's a lot going on right on this spot. Now, I thought the spot was related to where this takeoff is, and I just imagined, you have the takeoff there, you have the wiper going by it, and this is where everything was changing. But that's not the case, because if I can manage to show this right on this camera here, this might not work out so well. Because when you look at the volume control, which is right here, the tab is down near the loud end of the volume control. The quiet end is up here. So as you turn the dial quieter, you can picture this slider moving up towards the end here. It doesn't even get to this tab position unless you turn the radio way up. Way up doesn't seem to do anything particular, it's way down. So my thoughts around crossing this tap point, I guess would be the right word for it, this tab, is where everything is switching and changing, and no, it can't be the case. That has really thrown me for a loop. So what's really happening? I'm going to switch to a different copy of the schematic so we can study it more carefully here. So also, as you vary the volume tone from the weird spot down in the area where it's doing the motorboating characteristic really changes a lot as you turn the knob. So what's left of the resistor in here is having a big effect on this. It's part of the circuit. So we know that's part of the circuit. We know the tube is part of the circuit. Maybe we can figure out the whole circuit now and what's happening in it. And I don't give myself a lot of hope for this, but let's look at the schematic and just see if I can extract something out of it here. Okay, Jim, extract away. So we'll look here. It's much. I'm gonna zoom in on this area. We'll make it fill the screen better. I don't need to see the entire schematic. So here is the volume control. R8. The top of the volume control, the input to the volume control, is coming through this switch, either from the cartridge or down from the detector. Okay. So as I, in fact, slide this right to 0, you get some motorboating still. As you slide it up and up and up, at some point everything seems to go over the top of a hill. It seems to just switch around the other way. Things seem to reverse, or something happens when you move this up. What you're doing is you're increasing this resistance and decreasing this resistance. Why would increasing this resistance gives you more for this to chew on? The more the slider is slid down the resistor, the more there is here for, more supply for here. Supply what? So, the motorboating sound, the put 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 put, is usually caused by the AVC capacitor and its slow time constant. I think that's this guy here. So we have something. Let's say, so to get a feedback, whatever is coming out of the amplifying element, which would be this guy, must get back to the input here. It must get back to the grid. Okay, so it comes out. Down here, it's gone. Comes out. Goes over here. Wow. What is that? What is that connection? C35. What does that do? C35. 100 picofarads. 2,000 volts. So, wow, that certainly raises some interesting questions, doesn't it? Why do they think they need a 2,000 volt capacitor here? Got me. I don't know. I don't know. Okay. That's not going to help our situation, though. So how else can it get back to this grid? Well, can it get all the way up here? Can the output follow this? Come down here? Somehow get back in through here? What's stopping it is this guy. So this guy, he's a big capacitor. 36, C36. 4, it's not that big. 4. Here. Over to this wire, which is a negative, just goes back to the ground. Well, the job of this capacitor is to quiet all this. Stuff. Well, assuming it can't go up this way, that's a bad assumption. And it's getting back there somehow. So one way would just be amplified out the speaker and back through this feedback. And then it would putt because there's something wrong. So that would be the feedback circuit. That means if I open the feedback wire, the putt will end. So there's a little study I could do. Open the feedback wire. This is a solid wire. In the radio, it's a solid wire right to the bottom. Now this is another thing here. I have trouble understanding what they're doing with these volume controls, because you'd think the bottom here would just go to ground, but it doesn't. It goes to the speaker. For sure this is a feedback thing, and then they're manipulating it here. So feedback solidly to the bottom of the volume control. That's the part I don't understand. And then a bit of feedback shot through here, fiddled around with, shot out here, a little higher up in the tone control, or the volume control. Higher up? Is that the right word for it? And a little bit of feedback shot down here, fed through here, coming out here. On the other side of the volume control, fed right into here. For the life of me, I figured the only way to really analyze this properly is to draw the, 5 or 6 different circuits that result as you move this switch. Draw each one of them out completely, separately, and then look at them. I don't want to do that. That would have mistakes in it too. So now we know we're pumping it in the bottom. We're pumping it in here. R9, how big is R9? R9, not that big, 22K. So there's this breakover point when you turn the volume up and it kind of goes over some kind of hill. Is it because this resistance is becoming the same as another resistance? And what is being turned around? Now I just noticed a little dash on the cathode here. What is that? That's just a mistake, isn't it? That's just an accidental little... That doesn't mean anything, does it? Never seen anything like that before. I think it's just a piece of dirt. So this is solid. This resistor is solidly connected here. It's always doing what it's doing. R9, I just looked at it, didn't I? 22K. When I look at the potentiometer, I would say this tap is pretty much how they show it here pictorially. You get the bulk of the volume control resistance up here and a smaller amount down here. And for some reason they've taken this amount and parallel it. Why not really parallel it? You know what? You could flip this around. You could take this resistor and you could stick it right here and draw it as a resistor continuing from this point down to here. And then you could take this part of the resistor and you could redraw it where this one's sitting, here. And you would have effectively flipped around the schematic. So now the bottom of the volume control appears to be on ground and the tap appears to be... I lost what I was thinking. It just disappeared right out of my head. But it feels better to me if the feedback is shot in on the tab line, on this line. And what I'm saying is you could I mean, this is physically how it is in the radio, but electrically it's the same thing. If you took this wire and stuck it here, and took this wire and stuck it here, how different would it be? It's all fixed in place. You could, yeah, so it's almost better to think of this as the real bottom of the resistor, except you can't slide down this part with the control. You can slide down this part, but not this. So the volume control slider will slide. Did I really get it right when I said this is at, well, this is showing at the loud end, not at the quiet end. That means that very seldom do I ever operate this volume control past this point. So when it comes to the feedback and getting back, I pulled all these tubes out and the feedback continued. So the circuit is this way. It won't include this tube, but it could include this one. I could pull this out and see if there's any feedback. I'm pretty sure there won't be, because they're not going to hear anything. So I can't really pull that out and do that experiment. But I could look for the pumping sound, you know, up in here. Now what would that tell me? Well, it would just give me more information to put in my bucket of confusion. Well, one of these two, or maybe even both, are involved in amplifying the feedback. If the feedback is really something to do with the real feedback, the purposeful feedback, then yeah, both these tubes are involved. Could it? Yeah, because I pulled this one out, it went dead. For sure this is involved. This is involved. The volume control is involved. I just have to assume if I cut this feedback wire, it's over for feedback. But what if I just got rid of the feedback? That would disable all these tone things he's done. Goodness knows what this radio would sound like then, and we don't know. Maybe it would sound fine. These are tone controls, and I don't sit flipping from tone to tone to tone. I pretty much turn the radio on to the first snap and leave it. Now, what if I just eliminated the feedback? The engineer who designed this would roll over in his grave, assuming that's where he is now. Interesting experiment. Hey, there's something to do. Okay, I thought my way all the way to something. One of the techniques I've used from time to time in repairing radios is get rid of part of the radio that's causing problems. Just get rid of it. That's what we're going to try here. We're going to try that here. Now, I have a couple places I can get rid of the feedback. I can cut it off right where it starts. It starts right here. It actually starts way up here on the speaker terminal. This is the one that's conveying the speaker signal or the feedback signal into the switch. If I separate it here, other connections remain. But now it could be, can't really relate the schematic to the wiring that way. So the blue, I drew it in blue here. Blue wire comes here. Yeah, I just separate it right here, which is right here, and no feedback anywhere in the radio. Let's see what we got. We got lots of excess wire here. Many things on that terminal. Don't do it, Jim. Don't do it. Feedback to nowhere. Okay, here we go. Volume is in the switchover spot. Here we go. Power on. Speakers connected. This is an ABC monitor line. Let me stick a hopeless antenna on here. You know, I should have had the radio operating and then cut the wire when it was operating. What a bozo. Well, no feedback. Now we got to wonder what kind of radio we got here. Okay, full power, full voltage. Well, doesn't seem that bad. Let's get some kind of noise on it, some kind of signal on it. I don't like the hum or that buzz that comes out, but that's pretty high volume. Tell me this is a solution. Just get rid of it. This is a better. That's volume minimum. Turn it down is take the antenna off it. So I gather you saw what was happening there. Sound going down, back up, goes up quite rapidly. So I got the same spot thing going on. Now let's just see, can we figure out? So this back tab on here appears to be dead center. It would look to be center of the, I'm assuming, you know, the track in the volume control goes like this, and the slider goes up, and that's about halfway. It's about the halfway point. Yeah. Just as it's crossing that point. Why didn't I just cut it off the back, off the tab? You know, that's what I did before. That's when I got the radio here. I'd cut these. I'd cut this, and I'd cut this other wire, which I then restored, and we've been having trouble since. But I was having trouble before that. How bad is this? The problem again is I still cannot turn it down. Can't turn it down. It continues to amplify something even when the volume control is low, and that's when it motorboats. How does it continue to amplify? So the volume control is working in two directions at once. You know, there's supposed to be an input signal on the top of the volume control, and the bottom is usually taken to ground. Now I've just reasoned out that the bottom of this is taken to ground through this resistor R9. R9. What if that were open? R9. That's the 22K. That's the 22K. 22,000. But where are you? 22,000. Where's that? Right here. Right? It was open. I cut it open. R9 from the back tab. R9. Is R9 open? Power off. R9's open. There's no ground on the bottom of the volume control. $22K. 26 instead of 22. 26 instead of 22. Doesn't seem like something that would cause a problem like this, does it? Location of the red wire. So along with the resistor coming off, there's a red wire. I've traced this a number of times. Do it again. So it's this wire here. Goes to a terminal. I was just doing this yesterday, was I not? Comes down, blue here. Comes all the way over, meets up with C40 and R20. This is on S2D. S2D. R20 is 33. So S2D is here. S2D, is that really correct? S2D. So here we go. So S2D is indicated here on this piece of paper to be this side. Now the thing about this switch is the lugs and terminals on this side of the wafer are really attached to switches on this side of the wafer. That took me a couple of days to realize. So when they say this, that they show this as being S2D, are they showing where the terminals are, or are they showing where the switches are? Because they're on different sides. And here I am, how many hours into this, and I'm still not sure about that. So this resistor 22 is shown attached to S2D. So this has got to be S2D here. But on the diagram, S2D is shown there. So on the diagram, they're showing the switches. But on the schematic, they're showing the physical position of these. That's got to be what's going on here. It's just causing my head to peel away into parts. So I did put this extra capacitor in, didn't seem to do anything. It's not extra, it's according to what's on the schematic. So the red wire comes around to the back. Comes around to here. Attaches directly to one lead there. That makes sense. And the other side is going where it's going. It's good. Just verifying this. And then we have this these two capacitors I put in the back there. So what kind of cheat can I do to make it so the volume control will go to 0? Well, why won't it go to 0? That's a good question. Why the heck won't you go to 0? When I put this all the way here, that would be full volume. Jim, you've just got to, this has really just turned my head around in pieces here. The low volume's down here. So you are crossing this tab, but as we saw, the physical location of the tab's more in the center. Okay, I really, this is just really my life. Volume control. How do they work again? So when you turn the volume right down, this is sitting here. Now, how could it possibly, because it's not really sitting, it's not sitting. Oh, this is interesting. As you pass this point, you're kind of passing this grounded thing here. Now it's grounded through the resistor. But then you go on by, you could think of this as two volume controls tied together at this point and grounded. And a little volume control here and a little volume control up here. And the zero is here. Loud. And what's it going up on? It's going up on all those things that cause the motorboating. You know what I would say? Take this off, put it here. Put this resistor connection here. That wouldn't even necessarily, well, because right now what's happening is I'm getting down to the bottom here, and all I'm doing is I've now picked off the feedback. It's just feedback straight through. It's almost as if this could never work. How could this ever work? Like this. When I mess around this whole thing, I could end up with a tone response out of this radio that's just horrendous. Because who knows what all is going on down here. But that might be one solution to make the volume control go to zero. What if I just put it? No, a jumper. No, it doesn't make sense. This is the guy who's moving. Just stop there. Don't go any further. Why? I thought I disconnected this. It really didn't. I disconnected this. All this other stuff is still hooked up here. What if I just took it off the bottom of the volume control? There. You come down. Nothing, and then there's just nothing here. We just cut the lead right on the bottom of the volume control. That means you turn the volume up a fair ways, you get nothing, and then all of a sudden you get a lot. It'd be a lot better to move this down here. But the first step could be just cutting this. Cutting this. Cutting the bottom. Cut the bottom. Cut the bottom away. Should I put all the rest of that feedback back on? Could be some reason. So here's the bottom. Bottom's right here. I'm going to cut it in the same spot here where it's right here. Okay, so now we have a volume control with no bottom connection. The bottom connection is the tab here. Turn it down. It should be totally silent now. Okay, and we continue to cut away parts. That's how you do it. You just keep cutting stuff away until the radio works. It's a new technique. Okay, we're going to put a little bit of a noisemaker antenna on there. Noisemaker antenna. Oh, what did I hook up last time? It wasn't what I thought it was. Just a piece of wire. Volume down. So what if you try the different tone settings? Phono, 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 phono. Tone is the same everywhere. Now the question is the tone acceptable? Because this is acceptable. And I can still move this. Let's get some kind of signal coming out of here. We're going to pick somebody up, something or somebody up. And what would be best to try here? Well, we can try AM radio. Why not? That's where we are. Why did I just hear a thump? Can we possibly? It's just me. Can we possibly pick anything up on this radio? With me as the antenna. You still got volume. So, how's that happen? So, there's definitely nothing feeding in the top of the volume control there. Wait a minute. Bottom. This is injecting into the middle of the volume control. You know what? All I've got to do is bring this wire up, hook it to red wire. I lost my thoughts here. What I was thinking was there's an easy way to provide a ground right at the bottom there. Easiest way would be just to attach a ground at the bottom. The bottom is hanging open. Just ground it. Ground the bottom. Ground it. That's the word. That's the word. Ground the bottom of the volume control. What could go wrong with that? Wow. Now it's just a question of the tone, for sure. For sure. My God, you know, I should have thought of this a long time ago. I never used these different tone settings on this radio when I used it. I just always snapped it on and just left it. Come to think of it, it always kind of behaved weird when I think about it. It always had a super bassy sound, too bassy in the other tone positions. Okay, what are you gonna do? So we gotta get a signal in here. Okay, I'm gonna set things up so we can tune something in. Okay, so what I've done is I've put an outdoor antenna on it. That's what this is. Tuning on the shortwave band. Volume, kind of doing the right thing. And what do we get? We get a station right here. Where'd it go? So ignoring the distortion that's in the signal now, there's a lot of distortion. The tonal quality is okay. The distortion is here probably because I've disabled the feedback. What if I just do something crazy and stick the feedback wire into the back of the... I mean, I'm just completely thoughtless thing to do. Let me make contact back here. Nothing. Ooh. Yeah, there was something there. Basically, we've jumped out of the fire and out of the pan into the fire. Yeah, out of the fire into the pan. I guess either way is not so good. Interesting. Hey, what if we do this? So, feedback is used to eliminate harmonic distortion, and it's very, very effective. And it was discovered early on and applied to many, many radios, and almost everything, in fact. The cost of getting the much lower distortion is a little loss of volume. The benefit is it is such a powerful distortion fixer that you can have a pretty lousy amplifier and get away with it. So from an engineering point of view, it's very attractive. Much easier to get low harmonic distortion using feedback than to get it using nice circuitry. I suppose it would even compensate for things that might occur as the set ages. So I can't get along without it. I think that's the bottom line. Can't get along without it, can't get along with it. Okay, maybe that's enough for now. That's a fair bit. I got a little further into this, I think. Yeah, a little further into it. Yeah, I don't think I'm going to listen to any shortwave with this guy the way it is. I'm going to leave it here for today. It's another fantastic sunny day. Cats are outside. They want me out there too. So I'm going to go and attend to being outside, doing all kinds of yard work. I'm not sure what I achieved today, but it certainly opened a couple of doors here a little bit, I think. Boy. If somebody told me this is how I was going to spend my summer, boy. Thanks a lot for watching, and probably be in here tomorrow morning trying again.